Let's continue going through our quiz review. So question number 14, we have a polynomial function f of x equals 2 times the factor x minus 3 times the factor x plus 2 squared. Question A is asking for our degree. In order to get our degree, we add up our multiplicities. So that would be 1 plus 2, which makes this a third degree. And we know because it's odd that this is going to have an opposite in behavior. So I'm actually going to go ahead and start setting up my limits now. On the left side, our limit is written as the limit as x approaches negative infinity of f of x equals. And on our right side, it's the limit as x approaches positive infinity of f of x equals. So we know this is a third degree, which means our in behavior is opposite. And because the 2 is positive, that's going to make our right arrow go up towards positive infinity. And the left side will do the opposite, which is go down towards negative infinity. Question B is asking us to list the real zeros. So in order to do that, I need to set each one of my factors equal to 0. So if x minus 3 equals 0, then my first is x equals 3. And it says write it as an ordered pair, so that would be 3, 0. And my second factor is x plus 2. If I set that equal to 0, I get negative 2, 0. And we know that in order for the graph to cross through, the multiplicity of that factor has to be odd. And at x minus 3, we have our 0 of 3. We do have an odd multiplicity. So at 3, 0, it will cross. And at negative 2, 0, it's just going to bounce off or touch down. Excuse me. All right. Definition of y-intercept never changes. It is your y value when x is 0. So I'm going to use the function and figure out, well, what is my y value when x is 0? So I'm going to go ahead and set this up. And then in place of x, I'm putting in a 0. Which is going to simplify down to 2 times negative 3 times 2 squared, which is 4. And if that is multiplied through, you should get negative 24. So our y-intercept is 0, negative 24. Question number 15 is asking us to write a polynomial of least degree in standard form, which means the factors need to be multiplied. Excuse me. So the first thing I'm going to do is write the factor form. Factor form, we don't multiply. So we have y equals, and then every 0, excuse me, we flip the sign. So if I have a 0 at negative 4, that means I have a factor at x plus 4. If I have a 0 at 0, then I have a factor of x. If I have a 0 at x equals positive 2, then I have a factor at x minus 2. And if I have a factor of x equals positive 3, then I have a factor of x minus 3. So I'm not going to show my steps. But what I'm going to do is multiply these together, which will give me x squared plus 4x. And I'm going to multiply these together, which you can FOIL, you can make a box, you can do that whichever way you want. I'll set up the box. You feel free to pause the video at this time and see what you get. If you filled that in correctly, this should be your answer. My last step is to multiply these two. And when I multiply these two, I'm going to make one more box. It's going to be a little bit longer of a rectangle. And I have my x squared plus 4x here. And I have my x squared minus 5x plus 6 across here. And then I just fill in each square. So this gives me x to the 4th. This is negative 5x cubed. This is positive 6x squared. This would be a positive 4x cubed. This is a negative 20x squared. And this is a 24x. We have some like terms that we can add together. So our third degree terms can be added or combined. And our quadratic terms can be combined, which will give me a final answer in standard form of f of x equals x to the 4th. When I add these together, I get minus x cubed. And when I add these together, I get minus 14x squared. And when I add these together, I get, oh, sorry, I already added that. And when I add my last term, that would be a positive 24x. And that is my equation in standard form. Again, I always encourage you to try to pause the video and work out the question on your own and then come back and listen to the explanation. So we have write a polynomial equation in standard form again. This time I have a 0 of negative 5 with a multiplicity of 2. What that means is I have x plus 5 squared. And then I also have a 0 at negative 1 with a multiplicity of 1. So that would be x plus 1. So I really have three factors. I have x plus 5 twice, and I have x plus 1. All right, go ahead, pause the video, multiply this out, make a box, see what you get. All right, if you did that correctly, you should have x squared plus 10x plus 25. I'm going to make one more box. For this time, it'll be a little bit longer of a rectangle. So I have x squared plus 10x plus 25 across the top and x plus 1 down the side. So when I add those together or multiply these together, I get x cubed, a positive 10x squared, a positive 25x, a positive 1x squared, a 10x, and a 25. And again, our like terms are at a diagonal. So my final answer in standard form would be f of x equals x cubed and when I add these together, 10 plus 1 is 11. And when I add these together, 10 plus 25 is 35. 35x, and then I end with the 25, and that would be our answer. All right, let's look at question number 17. Question number 17 is asking us to look at the graph, fill out some key features about this graph. Number one is a polynomial function, so our domain is all real numbers. Now this graph is even. It looks like the lowest it goes is -2, and it's going up towards infinity on the y-axis. So my range would be -2 to infinity. Also, C is asking, what is the y value when x is 0? In other words, what is your y-intercept? So that represents this point, which is +4. So I'm going to write that as an ordered pair. And lastly, let's write our equation in factor form. Every time the graph touches the x-axis, we have to put a factor. This one has 4. So the first one is at -2, so that becomes a +2. The second one is at -1, so that becomes a x + 1. The next one is at +1, so that becomes x - 1. And lastly, we have a +2, so that would be an x - 2. Now we have a positive leading coefficient because both arrows are pointing up. So the beginning of our equation should be positive. So you can put an invisible plus sign in front to show that we have a positive. I mean, you can add a plus sign if you want to show that it is positive. All right. Add the arrows. So every odd degree has the same domain and range. That means that it's going up and down forever and left and right forever. What is the y value when x is -1? If I zoom in here, -1 looks like it's about here. So that's a little bit less than 10. I'm just going to round it to 10 though. So I'm going to say that it's approximately 10, or you can say y equals 10. It's approximately. All right, now let's look at our factor form. So I have 1, 2, 3 x-intercepts. So I'm going to make 3 parentheses. And at the first one, which is here, that's touching down at -3. So that factor becomes a +3. Also notice that it's bouncing off, which makes this factor squared. My next intercept occurs here, and that is at +1. It is going through. So that +1 factor becomes x - 1. And the invisible multiplicity on that factor is 1 because it does go through. And lastly, we have a factor or an x-intercept at the +4, which gives me a factor of x - 4. This is not going through. It's touching down, which makes that also squared. If I were to add these up, 2 + 1 + 2, that would give me 5, which is odd. And we know this is an odd degree because the arrows are opposite. Lastly, right arrow goes down, so I have a negative leading coefficient. So I'm just going to put a negative to start that out.